Perpetuity provides continuous payments. The payment rate is given by this piecewise function. Using annual effective 6%, the present value is x, calculate x. So here, the payment rate between time 0 and 10 is constant. The interest rate is always constant. So remember from lesson 93, whenever we have a continuous annuity, we have to see which case it is. And case one is about constant payment rate and constant interest rate. So in this case, interest rate is always constant. And for the first part of the annuity, which happens between 0 and 10, the payment rate is also constant at 1. So this first part of annuity is dealt with case 1 of lesson 93. And therefore, by equation 93.1, A of 10 will be 1 minus nu 10 over delta. And remember, when the payment per period is 1, then the present value is denoted by a n angle bracket and with this bar on it. So nu is the discount factor, which is 1.06 power negative 1, since the interest rate is 6% annual effective, and delta we know is ln1 plus I, so ln1 plus 0.06. And so the present value of this constant part of the annuity is 7.58. After time 10, the payment rate becomes variable. So you see now the payment rate is no longer constant, but it has this t in it, which means it's a variable rate after time 10. The interest rate is still constant. So now we are into case 4, where the payment rate is variable and the interest rate is constant. So in case 4, and the constant interest rate from the second part of the piecewise function is 1.03 power t minus 10. And so by 93.8, which deals with case 4, we have the present value of the second stream at time 10 would be from 10 to infinity, because these payments start at time 10 and they go forever. So 10 to infinity payment rate times nu power t minus 10, that we get from equation 93.8. And again, you can study lesson 93 again or watch lesson 93 again if needed. And we substitute f of t, which is 1.03 power t minus 10, and nu is 1.06 to the negative 1. And we have the power t minus 10, so it would be negative t minus 10 in the power. And the 1.03 to the t minus 10 can be broken into 1.03 power t and 1.03 to the negative 10. So we pulled out the 1.03 to the negative 10, which is a constant. A constant can be pulled out from the integration. And the 1.03 power t stays inside the integral. And similarly, the 1.06 to the negative t minus 10 can be broken into 1.06 to the negative t times 1.06 to the 10, because negative and negative make it positive. So we have 1.06 to the 10 and a 1.06 to the negative t. So again, the 1.06 to the 10 can be pulled out, being a constant, and the 1.06 to the negative t stays inside. And now these two can be combined, because the 1.06 to the negative t can go down as a 1.06 to the positive t. And since 1.03 also has a positive t on it, so this can be converted into 1.03 divided by 1.06 whole power t. And this is the present value of the second stream at time 10. And to get its present value at time 0, we pull it back through 1.06 to the negative 10, multiply by that, and these two stay like they are, and then the 1.03 over 1.06 equals 0.9717, and we have a whole power t. So this one, the 1.06 to the negative 10 and 1.06 to the positive 10, they multiply to give you just a 1. So we are only left with 1.03 power negative 10. And then this is the integral of a constant power a variable. And we know that a power x integrates to a power x divided by ln a. So this will be 0.9717 power t over ln 0.9717. And the limits of integration go from 10 to infinity. So remember, this is not here, we're not going to use the power rule, because in the power rule of integration, the base is a variable and the power is a constant. So that's usually what we encounter. So there we use the power rule. But if the base is a constant and the power is a variable, then this is the integration rule. So when we substitute infinity, we get 0.9717 power infinity. And now anytime you have a base which is less than 1, so the 0.9717 is less than 1 in absolute value. So anytime you have a base that is less than 1 in absolute value and you raise it to power infinity, that goes to 0. So that's why we have 0 for the upper limit. And then when you substitute 10, you get 0.9717 power 10. And here I combine the ln 0.9717 over here with the other constant that was standing. And this whole thing now simplifies when you put it in the calculator. It simplifies to 19.45. So this is the present value at time 0 of the second stream, which is given by the second half of the piecewise function. And the total present value will be the present value of the first stream, 7.58, plus the present value of the second stream, 19.46. And these two add up to 27.03. So the correct answer is A.